Welcome back, space enthusiasts. Today, we're diving into one of the most exciting topics in modern astronomy. Has the James Webb Telescope finally uncovered the boundary of the observable universe? Strap in, because this journey to the edge of the cosmos is going to be mind-blowing. If you're fascinated by the mysteries of the universe, make sure to hit that like button and subscribe for more out-of-this-world content. Let's get started. The universe is not just bigger than we can imagine. It is beyond our wildest dreams on almost every scale. Does the universe have a beginning and an end? Has the James Webb Space Telescope finally uncovered the edge of the observable universe? For as long as humanity has existed, we have yearned to understand the vastness of our world. We have diligently sought out boundaries and truths, expanding our knowledge in the process. In ancient times, the edge of the world was believed to be somewhere beyond the horizon. Today, we use powerful telescopes to explore the universe, searching for clues that might reveal whether it is finite or infinite. Now, with the James Webb Space Telescope, we may be on the brink of a groundbreaking discovery regarding this fundamental question. The universe undoubtedly has an edge, but what does this edge signify? Is it the true end of the universe or just the limit of our observable creation? An edge might also be a threshold leading to another universe or previously unknown dimensions. Just as our Earth has boundaries, so do our solar system and galaxy. However, the cosmos extends far beyond these familiar confines. As Neil deGrasse Tyson aptly points out, our challenge lies in comprehending just how vast and mysterious our universe truly is. The vastness of the universe exists more in our minds than in reality. The universe is beyond anything we can truly fathom. Our search for its beginning and end, whether in distance or time, is still carried out with relatively modest tools. Currently, our telescopes can peer out to about 46.5 billion light-years in every direction, giving us a view of a universe with a diameter of approximately 93 billion light-years. Yet despite this immense scope, no end is in sight. The sheer mass of stars, galaxies, and other phenomena within this range is staggering. Even with thousands of years, we could never explore and investigate every corner of the known universe. Driven by an unquenchable curiosity, we persist in looking further and further. We yearn to know if the universe has an edge and what it might look like. The James Webb Space Telescope, JWST, is poised to provide us with answers, potentially revealing this elusive boundary. Does the universe have a beginning? The JWST is already identifying objects in the darkest regions of space, some of which, according to our best measurements, are large, fully developed galaxies. As humans, we are simple-minded in our need to impose beginnings and ends on everything. We think in terms of facts, figures, and spatial limitations. However, the universe challenges these notions, inviting us to expand our understanding and embrace its infinite possibilities. When exploring the universe, we inevitably encounter the boundaries of thought and perception. Grasping the incredible dimensions of the cosmos requires us to stretch our understanding to its limits. The vastness of what we observe, the innumerable stars, countless planets, and bizarre cosmic phenomena, pushes our limited minds to expand. One might assume that astronomers and cosmologists who study these wonders would be among the most open-minded and free-spirited individuals. However, even these scientists must confront their own limitations and the boundaries that may have hindered their understanding of the universe. The James Webb Space Telescope, JWST, is challenging our space researchers like never before. Established theories and accepted truths are being questioned, and it's possible that our worldview is on the brink of another monumental shift, akin to the revelation that the Earth is round. The JWST has revealed 6 galaxies that are so ancient and perfectly developed that they defy our current understanding. Designed to peer into the dark ages of the universe, where the first stars were forming, the JWST is instead showing us phenomena that we never anticipated. This revolutionary telescope is pushing the limits of our knowledge and perception, suggesting that the universe is far more complex and mysterious than we ever imagined. Our journey of discovery is just beginning, and the JWST is leading the way into a new era of cosmic exploration. The James Webb Space Telescope, JWST, is turning our understanding of the universe upside down. Instead of finding protostars and baby galaxies, the telescope is revealing rows upon rows of perfectly formed, ancient-looking galaxies. This raises profound questions. Are we truly seeing the beginning and the temporal edge of the universe? Did the Dark Ages, a period we believed existed when the first stars and galaxies were forming, ever really happen? Or is it a concept we created due to our lack of knowledge? The discovery of 6 such galaxies is just the beginning. JWST has also identified a massive cluster of galaxies that should not exist so early in the universe's history. Galaxy clusters are massive groups containing millions of galaxies, and our previous understanding was that individual stars formed first, followed by star clusters, galaxies, and finally, galaxy clusters. So what does it mean when we find a galaxy cluster from a time when the universe was supposedly still very young? The problem lies not in the universe but in our perceptions and assumptions. The JWST is showing us countless galaxies with a redshift greater than 10, from an era long known as the Dark Ages. This challenges our belief that we understand more than we actually do. Consider another possibility. With an advanced telescope, we look further and further into space, focusing on the brightest spots, where the cosmic LEDs shine, because those are the areas we can see best. This is what JWST is doing, shedding light on parts of the universe we never expected to find in such a state. As the JWST continues to uncover these unexpected galaxies, it becomes clear that our journey to understand the cosmos is far from over. Instead, it is a voyage into the unknown, filled with surprising discoveries that challenge everything we thought we knew about the universe. Imagine using a telescope so powerful that you could see the walls of a room from a great distance. However, the tricky thing about observing the universe with our new super telescope, the James Webb Space Telescope, JWST, is that the universe is constantly expanding as we look at it. It's like trying to keep up with moving walls while developing better telescope technology and extending our range into space. One challenge in searching for the edges of the universe is that light takes time to travel through space. With the JWST, we see light that has traveled for 4 light years, 100, 1,000, or even 13 billion light years. This means we are always looking into the past. In everyday life, you also see the past, but light from an LED 60 or 100 meters away only takes a fraction of a second to reach your eyes, so it feels like you're experiencing space in real time. In the universe, the temporal dimensions are vastly different. For example, we see the nearest star, Alpha Centauri, as it was 4 years ago. We can logically infer that the universe must have been smaller 400,000 or 5 million years ago because it hadn't expanded as much. Yet despite our advanced technology, we have not succeeded in finding any signs of a spatial limit. Instead, the JWST has revealed even more intriguing evidence that the universe is far more complex and boundless than we ever imagined. The universe isn't expanding at the same rate everywhere, which suggests our cosmos might not have a uniform, homogeneous structure. Instead, it could be organized in ways we have yet to understand. Have you ever considered that searching for boundaries or a beginning might be a mistake? This new era of space exploration, spearheaded by the James Webb Space Telescope, JWST, invites us to abandon the notion of limited dimensions and expand our understanding of what we believe to be true. The JWST continuously reveals that the universe seems to have no limits. Rather than searching for an edge, the telescope has found structures that defy our expectations. For instance, JWST observed a distant galaxy and discovered a massive active galactic center that left scientists astonished. In the core of this young galaxy, formed only about 570 million years after the Big Bang, a quasar with a black hole 10 times the mass of our Sun was already active. Black holes in an active galactic nucleus emit an enormous amount of light, produced by the friction of materials spiraling into the black hole. These galactic centers can shine trillions of times brighter than our sun, breaking the boundaries of what we thought possible. The JWST is pushing us to rethink the universe's structure and our place within it. Its discoveries suggest that the cosmos is far more intricate and boundless than we ever imagined, urging us to look beyond traditional concepts of space and time. The James Webb Space Telescope, JWST, continues to amaze us, even in its search for exoplanets, revealing that we must abandon our notions of limits. To truly understand the universe, we need to embrace diversity and infinity. For instance, HIP 65426b was first identified by Hubble in 2017. But now, thanks to Webb's unique capabilities and highly sensitive spectrometers, we have even clearer data about this distant world. HIP 65426b is a massive gas giant, approximately 12 times larger than Jupiter. It orbits its star at a distance 100 times greater than the distance from Earth to the Sun, which is more than twice as far as Pluto is from the Sun. Using Webb's coronagraphs, cameras, and various filters, this planet has been imaged directly for the first time. This is remarkable, as most exoplanets are discovered through the transit method or other indirect techniques. These findings are just a glimpse into the incredible diversity and complexity of the universe, demonstrating that it would be foolish to search for an end or limits. The JWST is showing us that the universe is filled with countless phenomena, peculiarities, exceptions, and new dimensions waiting to be discovered. To truly grasp the vastness of the cosmos, we must open our minds and embrace the endless possibilities it holds. The James Webb Space Telescope, JWST, launched in December 2021, is the most advanced space telescope ever built. Designed to be the successor to the Hubble Space Telescope, JWST boasts a 5-meter primary mirror, allowing it to observe in infrared wavelengths with unprecedented clarity. This enables it to peer through cosmic dust and see the earliest galaxies that formed after the Big Bang. Its mission is to explore the origins of the universe, search for exoplanets with potential signs of life, and unravel the mysteries of star and planet formation. What sets JWST apart is its position in space. It's located at the second Lagrange point, L2, about 1.5 million kilometers from Earth. This position provides a stable environment with minimal interference from Earth's atmosphere and solar radiation, ensuring that the telescope can operate at its best. Before we dive into JWST's discoveries, let's clarify what the observable universe means. The observable universe refers to the portion of the entire universe that we can see or detect from Earth, limited by the speed of light and the age of the universe. Since the universe is about 13.8 billion years old, the farthest we can see is approximately 13.8 billion light-years away. However, due to the expansion of the universe, the actual edge is about 46.5 billion light-years away. This boundary is not the edge of the universe itself, but the limit of what we can observe. Beyond this boundary lies the unobservable universe, which remains a mystery. JWST aims to push this boundary by detecting faint light from the early universe, potentially revealing what lies just beyond our current observational limits. JWST's powerful instruments are designed to look back in time and capture the light from the first stars and galaxies that formed after the Big Bang. By observing in infrared, JWST can see through the cosmic dust that obscures many distant objects. This allows astronomers to study the formation and evolution of the earliest galaxies and stars in greater detail than ever before. One of the key goals of JWST is to identify the first light-emitting objects that emerged in the universe, known as Population 3 stars. These stars are believed to have formed from primordial gas composed mostly of hydrogen and helium, with very few heavier elements. Discovering these stars would provide crucial insights into the processes that shaped the early universe and led to the formation of galaxies. Since its launch, JWST has already made several groundbreaking discoveries. One of the most significant findings is the detection of ancient galaxies that formed just a few 100 million years after the Big Bang. These observations suggest that galaxy formation occurred earlier and more rapidly than previously thought. Additionally, JWST has detected the chemical signatures of complex organic molecules in distant star-forming regions. This hints at the possibility of life-sustaining conditions in other parts of the universe. The telescope's ability to analyze the atmospheres of exoplanets has also provided new insights into their compositions, potentially identifying planets with conditions suitable for life. The discoveries made by JWST are just the beginning. As the telescope continues its mission, it will delve deeper into the cosmos, uncovering more about the origins and evolution of the universe. Scientists are eagerly awaiting data that could answer some of the most profound questions in astronomy, such as the nature of dark matter and dark energy, which make up the majority of the universe's mass and energy. JWST's findings will likely pave the way for future space telescopes and missions, each building on the knowledge gained from this remarkable observatory. The potential to uncover the true boundary of the observable universe and what lies beyond is a tantalizing prospect that drives the continued exploration of space. The cosmic microwave background, CMB, is the oldest light in the universe, dating back to approximately 380,000 years after the Big Bang. It serves as a critical source of information about the early universe. While the CMB has been extensively studied by previous missions like the Wilkinson Microwave Anisotropy Probe, WMAP, and the Planck satellite, JWST's advanced instruments provide a new dimension to these observations. JWST can examine the CMB with higher resolution and sensitivity, offering insights into the universe's infancy. By analyzing minute fluctuations in the CMB, scientists can better understand the distribution of matter and energy in the early universe, leading to more accurate models of cosmic evolution. This deeper understanding could help pinpoint the precise conditions that led to the formation of galaxies and large-scale structures. Dark matter and dark energy are two of the most elusive components of the universe. Dark matter, which makes up about 27% of the universe, interacts with regular matter through gravity but does not emit or absorb light, making it invisible to traditional telescopes. Dark energy, comprising roughly 68% of the universe, is thought to drive the accelerated expansion of the universe. JWST's ability to observe the universe in infrared allows it to study the effects of dark matter on the motion of galaxies and the bending of light from distant objects, known as gravitational lensing. By mapping these phenomena with unprecedented detail, JWST helps scientists infer the distribution and properties of dark matter. Similarly, its observations of supernovae and distant galaxies contribute to our understanding of dark energy and its influence on cosmic expansion. One of JWST's most exciting capabilities is its ability to study exoplanets, planets orbiting stars outside our solar system. With its advanced spectroscopic instruments, JWST can analyze the atmospheres of exoplanets, identifying the presence of molecules such as water, carbon dioxide, methane, and even potential biomarkers that might indicate the existence of life. By observing exoplanets in the habitable zones of their stars, where conditions might be suitable for liquid water, JWST can assess their potential to support life. Discovering an exoplanet with a hospitable atmosphere would be a groundbreaking step towards answering the age-old question of whether we are alone in the universe. JWST's observations are shedding light on the processes that lead to the formation of stars and planetary systems. By peering into star-forming regions obscured by dust clouds, JWST can study the birth of stars and the accretion disks of material that surround them, which eventually coalesce into planets. These observations help scientists understand the conditions and timelines of star formation, as well as the mechanisms that lead to the development of diverse planetary systems. This knowledge not only informs us about the history of our own solar system, but also about the potential for life elsewhere in the universe. Black holes, especially supermassive black holes at the centers of galaxies, are among the most fascinating objects in the universe. JWST's infrared capabilities allow it to peer through the dust that often shrouds these enigmatic entities, providing clear images and data. By studying the environments around black holes, including the accretion of matter and the powerful jets they sometimes emit, JWST is helping to unravel the mysteries of how black holes form, grow, and influence their host galaxies. This research is crucial for understanding the role black holes play in the evolution of the universe. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos, and join us in unraveling the secrets of the universe. Become a Blasovia Science TV member today, and together, we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.